Hey everyone! So earlier today we worked on representing cyclohexane structures as what are known as chair diagrams. These chair diagrams are ways that cyclohexane is able to fold itself up such that it minimizes both torsional and angle strain. Drawing these types of structures rather than the flat hexagon type species that typically represent cyclohexane can be a little challenging. So I figured that this might be a good idea to set this out in a video of how to do this. This is my first attempt at making chemistry videos, so I do hope you bear with me a little bit. This might be a little rocky. But okay, so the first step in drawing a cyclohexane chair ring is to draw two parallel lines that represent the ends of the cyclohexane chair. And so I'll do that in red right here. There's one, and there's two. And what these are corresponding to, the lines that are representing this side of the chair and that side of the chair. Then what we want to do is create a second set of parallel lines, but that are perpendicular to these first red lines. And so I'll do that in blue. So we draw one perpendicular line coming in, and we draw a second perpendicular line from the other end of the other red line. And so these two blue lines are then parallel to each other, and then finally you simply connect the dots as such, and what you're left with is a cyclohexane chair species. An important part of drawing cyclohexane chair species, however, is the ability to draw both ring-flipped conformers, in the sense that what we're trying to look at is if we pull this point down and pull this point up, we can wind up flipping both the axial and equatorial positions of the cyclohexane ring. To do this, we want to draw the mirror image of the cyclohexane chair conformation in which we've first drawn. So what I'll do is I'll put up a mirror plane right here. And what you do is you do the exact same thing. However, your first initial set of perpendicular lines are simply tilting the other way. We then come in black and add our next two sets of lines. Extend that a little bit. And then we come in blue and connect the dots. And I'll tidy this up a smidge. There we go. And so what we've wound up doing then is drawing the flipped conformation of our chair species. So for example, if we were to place a substituent in the axial position on this first chair species, so let's make this 1-chlorocyclohexane. When we flip this species, this chloride is now going to be in the equatorial position. I'll draw in the hydrogen there for a little bit of context. So the best way to get pretty good at drawing these types of cyclohexane chair structures is really practice. And in all honesty, one of the great things that I did, I know when I worked on this as an undergraduate, was I practiced drawing it 10 times in a row, sort of like you used to do with your spelling words when you were in grade school. And after that point, it winds up becoming like riding a bike. It'll simply make sense to you. Well, I certainly hope that this was helpful, and tune in for more, hopefully better drawn chemistry videos.